This video is on simplifying and evaluating expressions using the power property of exponents, and it's lesson 40 in your book. So here's some exponent rules that we already use. We know that any number to the 0th power is 1, and any number to the first power is itself. We know that when we multiply like bases, we can add their exponents. We know that when we divide like bases, we subtract their exponents. And we know that when we have a negative exponent, we can move it to the other side of a fraction. So if it's in the numerator, we can move it to the denominator and our exponent becomes positive. If it's in the denominator and it's negative, we can move it to the numerator and it becomes positive. So raising a power to a power should really be no big deal. For example, if we have 2 to the 4th power and we take it to the 3rd power, that means that we are multiplying 2 to the 4th 3 times, which is 2 to the 4th times 2 to the 4th times 2 to the 4th. Now notice that all these bases are like, so we can add their exponents. 4 plus 4 plus 4 is 12. So 2 to the 4th power taken to the 3rd power is 2 to the 12th power. Now let's try some. Here are some examples that need to be in your notebook. So the first one we have here is 3 squared to the 3rd power. Now we're raising it to the 3rd power, which means we're multiplying it 3 times. So it's the same as 3 squared times 3 squared times 3 squared. Again, here we have all like bases, 3, 3, and 3. So 3 is still our base, and we can add our exponents. 2 plus 2 plus 2 is 6. In the second example, we have 4 to the 5th, and we're squaring it, or we're multiplying it 2 times. So we can rewrite it as 4 to the 5th times 4 to the 5th. Now we have like bases here. Our like base is 4, and we can add our exponents. 5 plus 5 is 10. So 4 to the 5th squared is the same as 4 to the 10th. And finally, we have 7 squared to the 4th power. That means we are taking 7 squared and multiplying it 4 times. So it's 7 squared times 7 squared times 7 squared times 7 squared. Now our like base all the way across here is 7, and we can add the exponents. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So that's the same as 7 to the 8th power. This brings us to the power of a power property. So it says if m and n are real numbers and x does not equal 0, then x to the m power raised to the nth power is the same as x to the m times n power. So whenever we have an exponent inside parentheses and an exponent outside of parentheses, we simply multiply the outside exponent by the inside exponent. Here's some more examples. Now, instead of doing 2 to the 3rd 2 times, we can say this is the same as 2 to the 3 times 2 power, because it would be 2 to the 3rd times 2 to the 3rd. Now I know 3 times 2 is 6, so this is the same as 2 to the 6th. Here I have a to the 6th to the 3rd power. Since I have my exponent inside the parentheses and outside, I can multiply those. A to the 6th times 3 power, and that gives me a to the 18th power. Notice I'm getting the same answer that I would if I did a to the 6th times a to the 6th times a to the 6th and added all the exponents. I'm just taking a little shortcut here. Now we have the power of a product property, and it says if m is a real number with x does not equal 0 and y does not equal 0, then xy to the n power equals x to the m, y to the n. Now what this means is, just like before when we have an exponent inside the parentheses and an exponent outside the parentheses, we still will multiply those exponents. However, that one outside the parentheses has to be multiplied by every exponent inside the parentheses. Now we could say that this started out as x to the 1st, y to the 1st, this whole thing being taken to the n power. Now, we would basically distribute this n to each exponent inside the parentheses. So it would be x to the 1 times m, y to the 1 times m, which is where we get the x to the m, y to the n. Here's some examples that need to be in your notebook. We're going to use the power over product property to simplify these. Now notice, this is 7 to the first power. Every factor in this term has a power. If there's none written, then we say it's 1. So I have a 3 outside my parentheses here, which means I'm going to have to multiply 3 by every exponent inside the parentheses. Now that means the exponent on the 7, which is a 1, the exponent on the a, which is a 3, and the exponent on the b, which is a 5. So I have 7 to the 1 times 3 power. Then I have a to the 3 times 3 power. And then I have b to the 5 times 3 power. Now when I simplify that, I've got 7 to the 3rd, a to the 9th, b to the 5 times 3, which is 15. And I do want to simplify that just a little bit further. 7 to the 3rd power is 243. And then a to the 9th, b to the 15th. So that is my simplified form. Now in this next example, I've got an exponent on my 2 here. It's an imaginary 1. And then the exponent on my y is a 4. And since I have a 3 outside the parentheses, I'm going to need to multiply this 3 by every exponent inside the parentheses. Now I have negative 2, notice this negative out here, to the 1 times 3 power. And then I have y to the 4 times 3 power. Now that gives me negative 2 to the 3rd power, because 3 times 1 is 3. Y to the 4 times 3 power, which is 12. And now I want to simplify. Negative 2 to the 3rd power is negative 2 times negative 2 times negative 2, which is negative 8, and then y to the 12th. And that is my simplified form. So we have an application in interior design that needs to go in your notebook. A square family room is being measured for carpeting. If the length of one side of the room is 2x feet, what is the area of the room? So what we're looking for is area, and we know that in order to find the area of a square, we take the side length and square it. Now in this case, our side length is 2x feet. So my area is 2x side length squared, or 2x times 2x. Now to simplify this, I have to multiply this 2 by every exponent inside the parentheses, and in both of these my exponent is 1 because there's 1 there. So I have 2 to the 1 times 2, or to the 2nd, and then x to the 1 times 2, or to the 2nd, and that leaves me with 4x squared. So the area of the room would be 4x squared. Now we have another property, which is the power of a quotient property. Now the power of a quotient property works the same way that the power of a product property works. When you have a fraction in parentheses, or a rational expression, and then you have a power on the outside, you multiply that outside power by all of the exponents inside the parentheses. So I'm taking x to the 1 times m power divided by y to the 1 times m power. It works the same way, except it deals with division instead of multiplication. For example, and here's some that need to be in your notebook, if you have 2x to the 5th power, or I'm sorry, 2x divided by 5, and you're squaring it, this square has to be multiplied by every exponent inside your parentheses. Now here you don't have any exponents inside the parentheses, so we assume they're all 1. I've got 2 to the 1st, x to the 1st, 5 to the 1st. And I'm going to multiply 2 by each of these exponents. So I've got 2 to the 1 times 2, and then I've got x to the 1 times 2, and it's all over 5 to the 1 times 2. And when I simplify that, that's 2 squared times x squared over 5 squared. That's a 5, by the way. And I can simplify it a little further by squaring 2 and squaring 5. So 2 squared is 4. And I've got x squared divided by 5 squared, which is 25. And since 4 over 25 doesn't reduce at all, 4x squared over 25 is my solution. Now, in the second example, it's the same thing. I have negative x squared, so I kind of have a negative 1 out there to the first power. And then I've got over 3y to the third, so there's like a 3 to the first power right there. I have to multiply this 4 by every exponent inside the parentheses. So I have my coefficient, my negative 1, to the 1 times 4 power. Then I've got my x squared, so x to the 2 times 4 power, all over my 3 to the 1 times 4 power, and my y to the 3 times 4 power. Now to simplify this, I've got negative 1 to the 4th, because 1 times 4 is 4. And then I've got x to the 2 times 4, which is 8, all over 3 to the 1 times 4, which is 4. And then y to the 3 times 4 power, which is 12. Now I can simplify my constant, so negative 1 to the 4th power is going to give me a positive 1. If you put that negative 1 to the 4th power in your calculator, make sure that you put that in parentheses. So I've got 1x to the 8th power, all over 3 to the 4th power, and 3 to the 4th power is 81, and then y to the 12th. Now, since 1 over 81 doesn't reduce any, that is our solution. All right, and that is all.